I'm exploring how changing the number of iterations, NITER, and batch size, BATCHSIZE, in scikit-learn's MINIBATCHDICTIONARYLEARNING affects a dictionary learned from many images. I'm considering the effects on performance and computing time. More iterations mean a better dictionary, but it takes more time. This is true. Larger batches mean fewer updates per cycle, so each cycle is faster. Even if more cycles might be needed. This is also true. Smaller batches add more noise, which doesn't guarantee better accuracy faster. It often takes more iterations to reach the same accuracy as with larger batches. This statement is false. The batch size affects how close the model gets to the best dictionary and how quickly it gets there. It does not have a negligible impact. This is false. This sets the stage. I'm working with a massive image dataset and a machine learning algorithm that processes it in chunks, mini batches. I want to understand the implications of adjusting the number of times the whole, or part of the, dataset is processed and the size of those chunks. This is the title. It summarizes what this whole problem is about. How different settings within the algorithm affect its results and the speed of processing. I see n_iter as the number of times the algorithm completely goes through the entire dataset, or a smaller part of it, in mini batches. Think of it like this: the more times you go through and refine your dictionary, the better it will become. It's like polishing a gem. The more you polish it, the more brilliant it gets. But, obviously, more polishing means more work. Here, batch_size is the number of images I use in one polishing step. A smaller batch size means I use fewer images per step, which might save some memory. However, this can also introduce noise into the process, like making uneven strokes when polishing the gem. A larger batch size, on the other hand, offers smoother polishing but needs more resources for each step. This is the final result of the algorithm, a collection of patterns or features that it discovers in the images that I'm feeding it. It is like the polished gem itself, the improved and refined representation of what I started with. The quality of the final learned dictionary depends on the parameters, n_iter and batch_size, I use. I'm exploring how changing the number of iterations, NITER, and batch size in scikit-learn's MiniBatchDictionaryLearning affects the results. We're focusing on how these changes impact the quality of the learned dictionary and the time it takes to train the model. Think of it like baking a cake. More iterations are like mixing the batter longer. It might taste better, higher quality, but it takes longer. Batch size is like how much batter you mix at once. Bigger batches are faster but might not give you perfect results every time. Let's figure out which statements are true about the effects of the number of iterations, NITER, and batch size on the performance of MiniBatchDictionaryLearning for a really large image dataset. It's all about understanding the trade-offs between model accuracy and how long it takes to train the model. I will carefully evaluate each statement about the effect of the number of iterations, NITER, and batch size on the model's performance and computing cost to find out which ones are correct. This is where we analyze if increasing the number of iterations or the batch size leads to a more accurate or efficient model. I would add a graph here to show you the relationship between the number of iterations, NITER, batch size, the quality of the dictionary created by the model, and the time it takes to train it. This visualization would be awesome for understanding the interactions. I'm looking at how changing the number of iterations, NITER, and the batch size, BATCHSIZE, in scikit-learn's MiniBatchDictionaryLearning affects the results. I'll explore how these parameters influence the quality of the dictionary we create and how much computing power it requires. This is the core question. I need to carefully evaluate each statement considering the implications of changing NITER and BATCHSIZE on both the quality of the learned dictionary and the computational resources needed. This refers to a specific machine learning algorithm in scikit-learn. It's designed to work efficiently with large datasets by processing them in smaller chunks called mini-batches. This is the number of times the algorithm goes through the entire dataset, or a subset. More iterations usually lead to a better dictionary, but it takes more time. Think of it like polishing a gem. More polishing, iterations, improves the shine, dictionary quality, but takes longer. This is the size of the smaller chunks of data I process during each iteration. Smaller batches use less memory, but might make the process noisy and slower to converge. Larger batches are faster per iteration but might need more iterations overall to get a good result. It's like dividing a large task. Smaller batches are easier to manage, but require more steps. Larger batches are faster per step but might need more steps in total. I'm analyzing the effect of changing the number of iterations, NITER, and the batch size, BATCHSIZE, in Scikit-Learn's MiniBatchDictionaryLearning algorithm. I'll focus on how these changes influence the algorithm's performance and computational demands. This parameter controls the number of times the algorithm cycles through the data. More iterations mean more chances to refine the dictionary, typically leading to better results but increasing processing time. Think of it like repeatedly polishing a diamond. You'll get a better shine, but it'll take longer. This determines how much data is processed at once during each iteration. A larger BATCHSIZE means fewer, but potentially more computationally expensive, updates per iteration. A smaller BATCHSIZE leads to more frequent, but potentially less computationally expensive, updates. It's a trade-off between computational cost per iteration and the number of iterations needed for convergence. Imagine painting a mural. You can use large brush strokes, large BATCHSIZE, for speed, or tiny brush strokes, small BATCHSIZE, for detail. I'm evaluating the accuracy of several statements about how changing NITER and BATCHSIZE impacts the dictionary learning process and its computational cost. I will evaluate each claim's validity. I agree with this statement. More iterations provide more chances to improve the dictionary, but naturally, it takes longer to compute. I concur. Fewer updates per iteration due to a larger batch size generally translates to lower computational cost per iteration. I disagree. Smaller batches introduce more noise, potentially hindering convergence and not guaranteeing better accuracy with fewer iterations. I disagree. The BATCHSIZE influences both the speed and, to an extent, the quality of the learned dictionary because of the stochastic nature of the algorithm. I'm analyzing the effect of the number of iterations and batch size on the performance of MiniBatchDictionaryLearning, a machine learning algorithm used for dictionary learning. It's a crucial part of understanding how to tune the algorithm for optimal results. I agree that increasing the number of iterations generally improves the dictionary's quality. Think of it like this. Each iteration is a refinement step, so more steps generally lead to a better result. However, more steps naturally mean more computation time. I find that increasing the batch size reduces the computational cost per iteration. A larger batch size means the algorithm processes more data points at once, reducing the overhead of processing many small batches. However, it might require more iterations to converge to a solution. I disagree with this statement. A smaller batch size introduces more noise, which is not always better. While it might seem intuitive that smaller batches lead to a better representation because they capture more detail, this often requires many more iterations to achieve similar performance as a larger batch size. It might even converge more slowly. I also disagree with this statement. The batch size does have an impact on the final dictionary quality. The algorithm's inherent randomness means that the choice of batch size directly affects how the algorithm explores the data space and therefore the final solution. It's not just about speed. I'm analyzing how changing the number of iterations, NITER, and batch size affects the MiniBatchDictionaryLearning algorithm. It's all about finding the sweet spot between accuracy and speed. I'm evaluating 4 statements about how tweaking NITER and batch size affects the quality of the dictionary we build and how long it takes to build it. This is simply the number of times the algorithm cycles through the entire dataset, or a chunk of it, in mini-batch learning. Think of it as the number of times you refine your dictionary. More iterations mean a better result, but it will obviously take longer. This is the size of the dataset chunk the algorithm processes in each iteration. A smaller batch size means more frequent updates, while a larger one means fewer, but potentially larger, updates. I need to consider the trade-off between computation time per iteration and the overall number of iterations. This refers to how good the dictionary learned from the data is. A higher quality dictionary will better represent the input data. This is simply how much computing power and time the algorithm needs to complete. I want to find a balance between computational cost and achieving a sufficiently good dictionary. I agree with this. More iterations give the algorithm more chances to improve the dictionary, but each iteration adds to the processing time. I'd agree here too. Larger batches mean fewer updates per iteration, making each iteration quicker. I disagree. While smaller batches might capture fine details, it doesn't guarantee a better dictionary faster. In fact, it often takes longer. I disagree here. The batch size affects how the algorithm learns, ultimately influencing the dictionary's quality, not just the training time.